Hey guys, what'd you find?
Hey Ken, let's just say there's plenty of room for improvement.
We're at about 4,800 CFM50.
You know, let's make clear what we're doing here. We're pressurizing the whole house, right?
Yes. What we're doing is with this fan, we're forcing air into the house to reach a certain pressure. And the amount of air that it takes to reach that pressure tells us how leaky the house is.
Okay, what is that 4,800 CFM in easy to understand terms?
That's about a 470 square inch hole to the outside.
It looks something about like this size.
Wow, that looks like about the size of a small window being left open year round. Where's that air coming from?
Well, that's coming from, round leaky windows, doors, ceiling fixtures, just little places that it can find a way into the house. One thing that we can do is we can tape off all the supply and return grills and rerun this test and find out exactly how much is duct leakage and how much is infiltration leakage.
So we'd find that by subtracting that number from the 4,800?
Correct.
That sounds like a great plan, but I want to make sure we all understand what we're talking about here. A return air vent takes air from the house to the AC unit.
Correct.
And a supply vent is air coming from the HVAC equipment into the house.
Right.
Okay, it sounds like a plan. Let's do it. All right, all sealed up. What do we got?
About 3,400 CFM50. That's about 340 square inches.
Oh, that's a lot.
That's about that much.
That much overall, which means this is the duct leakage we're looking at.
Correct.
Well, I know you guys have some equipment to help us identify those leaks, but the rest of this, how do we identify and take care of that?
Earlier today, Charlie and I took a tour of the home to look for the standard culprits that are in a home of this age, and we found them.
Can you show me?
You bet.
All right, let's go.
Okay, well, the first thing that we noticed was the separate combustion vent here, which is supposed to be connected to the outside, is also connected to the attic. And we also have this vent here in the door, which is connected to the inside. So this is a really big hole.
So you're saying this vent makes a connection from the inside of the home to the closet, into the attic, then ultimately outside?
Exactly.
How do we fix that?
Well, what we want to do is we want to get rid of this combustion air here. And there's a couple alternatives we need to do. We can either take this piece of equipment and move it outside, or get a sealed combustion furnace to where we can eliminate these vents, or we can just move to a whole nother heating source.
Okay, great. Did you find anything else here?
Yes, we did. We could shut this door.
Sure.
Earlier today, I took this return air grill off and found that the return is actually connected to this wall cavity, which is connected to the chimney flue. So what it's doing is when the air handler is running, it's pulling attic air down this wall cavity and into the return itself.
So it's connected through the chimney?
Well, it's not so connected to the chimney, but it's using the sidewall of this chimney as an air path to get to the attic.
I see.
So when this air handler is running, when you're trying to air condition your home and keep it at a 78 degrees, we're pulling in the middle of the summer, you're pulling 160 plus degree air right into the return system itself, and you're mixing 160 degree air into the 78 degree air and trying to cool it. So instead of the air handler being able to cool your home efficiently, it's completely out of whack.
Is this a pretty common problem?
It's a really common problem for this style platform for the age of the home. This home was built in 1975, but just recently with the building sciences that we're using now, we've identified this as a very common problem.
So which box of leakage would this fall into on our chart?
This would fall under the duct leakage box.
Okay. Anything else we've learned here?
Well, you know that it's safety first.
Right.
And we have a fireplace sitting right here, right next to this huge sucking force of the furnace. And when you have a fire going, a nice hot raging fire, the chimney's drafting fine. All the carbon monoxide and flue gases are exiting the fireplace. But when this burns down to a really low ember and coals, it's still producing carbon monoxide.
So you're saying that at night, everybody goes to sleep, we still have some hot embers, the chimney's producing carbon monoxide, and it gets sucked into through the vent and into the whole ductwork system and blown out throughout the whole house?
Exactly. Potentially very dangerous scenario right here.
Okay, so it seems to me like we need to get this return air platform moved away from the fireplace. Is that right?
Exactly.
Okay, boy, I bet the homeowners are glad you came by today.
That's right. Safety first always.
Why don't we take a look at what else you've found?
Let's do that.
All right. Okay, the dreaded laundry room. What'd you find in here?
Well, we've got about the same scenario we did with the furnace closet. We have a gas water heater in here that has upper combustion air, which is connected to the attic and connected to the outside.
Okay.
The clothes dryer in this room moves 200 CFM of air out of this room. We want to make sure that it's not getting it out of this closet.
Okay.
Since we can't see air, what we're going to do is with the smoke pencil, we're going to put smoke into the air so we can actually see where the air is traveling.
Okay, can we do that now?
We can. Charlie, can you get me a smoke pencil?
Sure I can. Here you go.
Good, thank you.
So what are we doing, Ken?
We're going to take the smoke pencil and put it into this combustion vent here and close the door. And why don't you go ahead and turn on the clothes dryer.
There you go.
And what this is telling us, with the smoke that's coming out of this grill right now, the clothes dryer that's evacuating 200 CFM of air out of this room, it needs to get it back, and where it's going to get it is from the largest, easiest hole it can find, which is right here. It's taking air out of this closet, which is taking air out of the upper vent, which is pulling out of the attic and also outside. And at the same time, we have the possibility that it's actually getting some of its air out of the flue pipe for the water heater. What the flue pipe does is it's allowing all the carbon monoxide and carbon dioxide that the water heater produces to vent to the outside, and we're changing the direction of that flue pipe, and so instead of it evacuating it to the outside, it's pulling it into the house.
That sounds dangerous.
It's very dangerous. One thing that we're doing as we work on this home, we always got to remember health and safety first. So those are the issues that we want to resolve now.
So what can we do to fix it?
Well, what we can do to fix this problem is we either install a sealed combustion water heater or put the water heater outside.
Or we could do the electric water heater too?
They could go to electric, but that would be quite an expense to run a designated electrical circuit to this side of the house.
But doesn't the backup for the solar require electricity anyway?
It does, so switching to electric would be a good option.
So you want to go up on the roof?
That'd be great.